Howdy, folks. It's me, your teacher, Mr. Bluehead, here with you today to go ahead and give you your 5.3 section video, Time Marches On. On the screen right there, you go ahead and see your bell ringer. You know what to do with that bell ringer. You go ahead and post it up there on edmodo.com. Let's go ahead and get started. Here's our objectives for today. We'll go ahead and explain how geologic time is recorded in layers of sedimentary rock. Hey, what are you doing? This is my job, not your job. You need to get out of here. You're going to scare the kids. What? Would I scare the kids? Yes, you would. Time to go. See you later, folks. Bye-bye. We're going to explain how geologic time is recorded in layers of sedimentary rock. We're going to explain how the geologic time scale illustrates the occurrence of processes on Earth. And we're going to identify two kinds of environmental changes that may result in decrease in the number of species that exist. And lastly, we'll explain how the fossil record provides evidence of changes that have taken place in organisms over time. Let us begin. Dun, 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 dun. The Earth is 4.6 billion years old, ladies and gentlemen. 4.6 billion years old. Paleontologists find a record of Earth's history and rock formations, fossils around the world. That's what we've been talking about this whole chapter, as we've been talking about the geologic column, the fossil record, those different things. We use those different things together to combine to find out how old the Earth is. And we've discovered that the Earth is approximately about 4.6 billion years old. Now, if we look at Dinosaur Monument in Utah, we can go to that place in Utah and we can find dinosaurs. And that dinosaurs were inhabited by dinosaurs. That area was inhabited by dinosaurs 150 million years ago. Now, that seems like a long time. But in reality, when we talk about 4.6 billion years, 150 million years is about 3% of the Earth's history. It's not very much time in spatially speaking between the 4.6 billion years. All right. Now, when we look through, see there, I was right. I told you it's only 3% of the time. When we look at the rock record and geologic time, there's several places on Earth that are good places to go to study this. Now, one of the places in North America is the Grand Canyon. And the reason for that is because we can see almost half of the entire Earth's history in the rock layers of the Grand Canyon. So that's one of the best places to go in America to go and study these rock formations and the history of the Earth. Another place that we can go, well, right there you go, 2 billion years, that's almost half of Earth's history. There you go. See, gotcha. Another place we can go is called the Green River Formation, which is over in Wyoming, Utah, and Colorado. Those rocks are thousands of meters thick, and inside those rocks we find all kinds of fossils. All right, we find fossils of snakes, we find fossils of leaves, we find fossils of turtles, we find fossils of fish. All those different things we find inside Green River, Utah area. Those are very easily those areas are easy for us to find these fossils. So right here would be a fossil of a leaf. Right here would be a fossil of an insect. It kind of looks like a dragonfly. Right here would be a fossil of a fish. And over here is a fossil of a turtle. So all these different things, we can find these fossils. And this right here is a picture of the Green River in Wyoming, Utah, Colorado, those areas. All right. So we can find fossils in those areas. Those are good places to go. Now, we talked about the geologic time. And haven't really talked about the scale, exactly how do we really do the geologic time and how is it divided. Well, what we do is to make things easier, we go ahead, the scientists, the geologists have gone ahead and divided the Earth into, or the Earth's time scale, the geologic time scale, into several different manageable chunks. So we can study these manageable different chunks individually. Now, there are 4 major eons when we talk about it. We have the Hadean, the Archean, the Proterozoic, and Phanerozoic. This is the oldest eon. This is the next youngest, and this is the eon that we happen to be in. We're in the Phanerozoic eon. Now, a mnemonic to help us remember the way that these 4 eons would be: hearts are pretty passionate. Hadean, Archean, Proterozoic, and Phanerozoic. All right, so when we look at this is the geologic time scale. Now, you have the same thing in your book. You can look at that in your book as well. It's on page 142. You can look at this in your book. Now, you can see that the Earth is divided, the time scale is divided into eons, and then those eons are divided into eras, those eras divided into periods, those periods divided into epochs. All right, so then again, and also, since this is the oldest going to the youngest, This is the oldest. This is the oldest going the youngest, and this is the oldest going the youngest. So right now we're in the Holocene epoch. If we were to look at this and try and figure out where we are, where exactly we are on this geologic time scale, we are in the Holocene epoch in the Quaternary period in the Cenozoic era and the Phanerozoic eon. Okay, so if you wanted to find out exactly where we are. Now, if we look at this, how do we divide this? Now, the largest division, when we talk about the eons, periods, the epochs, and those things, the largest division would be the eon. That's the largest division in time. And of course, we already talked about the four divisions, or the four eons, which are the Hadean, the Archean, the Proterozoic, and the Phanerozoic. We already talked about those four things. After the Phanerozoic is then, well, actually all of the eons are, but we're going to just talk about the Phanerozoic because that's the one we're in right now. The Phanerozoic is then divided into three eras, and the second largest division of time. Okay, so those eras, after the eon comes an era, that's the second largest division of time. Then we have our periods, and our periods are after the eras. So you have the eon, then you have an era, and then you have a period, and that's the third largest division of time. And lastly is the epoch. That's the smallest division of time. That's the fourth largest division of time. So you have the eon, you have the era, you have the period, and you have the epoch. All right, that is the four layers of time, or how we set time. Now, here's a quick video we're going to watch real quick, so you guys can get this idea in your head about what it actually would look like, what this time scale really looks like. Here we go.
The 4.6 billion years of Earth's history are represented on the geologic time scale. The geologic time scale is divided into four eons: the Hadean, the Archean, the Proterozoic, and the Phanerozoic. These eons are further divided into smaller periods of time. If the geologic time scale were organized on the face of a 12-hour clock, the first moment would represent the beginning of Earth's geologic history. Each hour would represent 383 million years. Each minute on the clock equals 6.4 million years, and 1 second on the clock equals 106,000 years. Human civilizations have appeared only within the last second on this clock.
Okay, so you guys get a better idea of what it looks like when we're talking about these time periods. Okay, now the boundaries between these time periods are, some of them are very easy to define and some of them are not. Some of them are marked by index fossils or the disappearance of index fossils. When those index fossils disappear, then that geologic time actually ends as well. Others of them, you have to really study paleontologically that era to really, or that time period, to really find out when that time period ended. So some of them are not very easily discernible just by looking at the index fossils being gone. All right. Others, some of them you really have to look at. Now, we can also tell the appearance and disappearance of species based on the number of fossils in a rock layer. If we see one rock layer and there's a whole bunch of these fossils in it, and the next rock layer there's none, we know that a mass extinction event happened that caused those fossils not to be in that next rock layer. Something had to happen to this rock layer at the end of this rock layer for them not to be there, because otherwise they'd be there. All right. Or if the opposite is true, if there was none here and all of a sudden there's a whole bunch here, all right, then we know that there was a sudden increase in the species as well, and something had to have happened that caused that sudden increase in the species. If you look at this, this is the Hallucigenia sparsa. It appeared in the Cambrian period when the number of marine species greatly increased. So this is a fossil that we saw that happened when marine fossils greatly increased. All right, now, we can see when they dramatically increase. We can also see when they dramatically decrease. A mass extinction event is an example of, or a mass extinction event is something where all of the organisms died at a certain period in time. However it happened, sometimes it can be over a gradual period of time, or sometimes it's very quickly. All of a sudden, all those organisms are gone the very next rock layer. Now, when we look at our geologic time scale, we look at some eras. Remember, we're talking about the Phanerozoic eon right now. The Paleozoic era is the old life. The Paleozoic era has lasted 543 million to 248 million years ago. This is where the first time we really have fossils. Up until this Paleozoic era, we really didn't have fossils to be discovered. So the previous, the Proterozoic, Archean, Hadean eons, we didn't really have fossil life in those eras. Okay. In this time, in the very beginning of it, the marine life started flourishing. In other words, a lot of marine life in the Paleozoic era, at the very beginning of the Paleozoic era. Towards the middle of it, all of the modern land plants have appeared. So we see all the trees and major land plants that have appeared. And by the end, we have amphibians and reptiles living on land and in the sea as well. We start seeing that as well. And this is what an artist's rendering of what life would look like in the Paleozoic era. All right, you see fish and you see land and you see trees and that kind of stuff. Now, the Paleozoic ended with the largest mass extinction event in the Earth's history. This is in Earth's history. Now, remember, dinosaurs aren't around here. But this is the largest mass extinction event happened. And some people think, some scientists think, is because of ocean changes that caused an extinction. We don't know. But nearly 90% of all species died at the end of the Paleozoic era. Then we have the Mesozoic era, which is the age of the reptiles, and this is when dinosaurs started to roam the world, roam the land and stuff. Dinosaurs dominated the land. There were smaller mammals appeared about the same time that dinosaurs did, but we had to compete, or those mammals had to compete against the dinosaurs in order to survive. Birds did appear in the late Mesozoic era, and from there. Now, at the end of the Mesozoic era, about 15 to 20% of all species on Earth became extinct. In that mass extinction event, we think had to have happened from a global climate change that caused those reptiles to die off. Now, was it from a comet? We don't know, but something changed the climate of the Earth that caused those reptiles to die off. And then the Cenozoic Era, which is us, the age of mammals. Cenozoic Era began 65 million years ago and continues to the present. This is when mammals ruled the Earth. During the Mesozoic, the mammals had, well, I talked about that already. So after the mass extinction event in the Mesozoic Era, the mammals, we flourished. We started being more and more of us because we were better suited for the environment that was left after the end of the Mesozoic Era. All right. Some of these traits were regulate our internal body temperature and develop young inside the mother. Those things helped us be able to survive that mass extinction event that happened at the end of the Cenozoic Era. Now, I mean, not Cenozoic, the Mesozoic Era. All right. So now here is your review. This is your 5.3 section review. I'm going to be quiet and let you read. Okay, well, I hope you enjoyed 5.3. This has been another Mr. Lewis production, and I will see you in the future.